one of my last episodes, I talked about one of the reasons, or maybe excuses, that I had for not doing videos for an extended period of time was that I was doing some significant upgrades to the shop. And I wanted to take a moment on this video just to start with a quick glimpse into one of those upgrades. And here it is. On the right, you will see the stool I've been using for like 20 years. And I've just done an upgrade to a new stool for the shop. Isn't this exciting? Look at the old one. Small, hard seat, fixed height, and now wide for my fat butt, rhino seat, little bit of flex to it for cushion, adjustable height, foot ring. Look at that. I am like moving up in the world right here. It feels good. There's a little bit of a bounce to it, which is kind of like reminds me of hippity hop from the day. Is that dating myself? That's not good. Okay, enough talking about my new butt-friendly seat. Let's get back to the project. The first thing that we've got to do in order to get this alignment and validate everything is in perfect alignment with the neck is to actually mount the neck. And I realized after I did the last video that I haven't even drilled the holes for the neck plate yet. So I figured this episode we're going to do that, and then we're going to validate the alignment by checking out the bridge position, and we're going to drill those holes, and then we're going to drill the holes for the spring claw in the back, and we're going to get that mounted and throw a couple tuners in and a couple E strings on either side, and we're going to validate the alignment and the spacing of this whole thing as we go. So that's going to be what we're working on today. That sound exciting? Sounds like a lot of work to me, but it's important work. The attention to detail in this part is going to be one of the most critical parts to the guitar playing. There's many critical spots, but this is certainly one of them. And if you have a little bit of error here, a little bit of error in a different area, and another area, they all add up to a lot of error, and it's not a good playing guitar. So let's get right into this. First thing I'm going to do is I'm going to drill the holes for the neck plate and the screws that are going to go through. Now, most of the time, and we've talked about this before, you will see folks using the wood screws. That's the industry standard, honestly. And it would probably be a perfect solution in probably most of the scenarios. The only scenario that I've really found that these aren't the greatest thing is for kind of a tweaker and a modder like myself that's maybe taking the neck off and rebuffing the body or trying different pickups and, you know, taking the neck on and off several times, and then these begin to loosen up and they begin to strip out and it becomes an issue, and then we got to shove the old toothpicks and glue in there and re-drill the holes, and hopefully it has something, you know, to bite into. Not a common problem with most pure players, but for me, I don't like that. So instead of using screws on a bolt-on neck, I am actually going to use bolts. Okay, machine bolts, and combine those. Those are stainless steel machine bolts. They're going to be combined with stainless steel inserts, and these are 832 is the size. Into the neck itself. So we're going to go over the process of drilling these holes, getting the alignment transferred to the neck, and getting the holes drilled perfectly for the threaded inserts, and how we then mount those threaded inserts, and then we'll go ahead and mount that neck, and then we can go into the alignment process. It may be too much information for all-on-one video. So if I feel like it's going too long to give the detail that I want to give you guys, then maybe we'll just cut it off and do another step later. But let's get into it and see how it goes. All right, looking over my shoulder, we've got the neck heel, we've got the neck plate, and for me it's just a visual at this point in time. I know my template was such that where this plate fits with just a little bit of border of wood around the edge is going to be perfect alignment. I will simply draw and trace the hole pattern right in there. Now the screws that I'm using, I mentioned before, are 832, but if we look at this, they're approximately 4 millimeters. So if I look on the calipers, the next typical drill bit size increment that I have is 3/16. So that is what I'm going to use, is 3/16 for these 832 bolts. That will give a little bit of side-to-side play to ensure that the bolt drops perfectly through without binding, and then once it grabs into the threaded insert, it will create the mechanical leverage needed to get a really, 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 3 reallys strong neck joint. Not trying to overcomplicate this process, so what I'm going to do is just take my spring-loaded punch, and I'm going to take and put a hole right dead center. Dead center is a visual thing for me. So I'm just going to punch one, and I'm going to make sure it's perceived visually to be in the dead center of that. If it's off a little bit, I'll adjust it by then taking that and angling another hole at a slight angle, and then I'll stand it up to where I perceive to be closer to dead center, and I can kind of shift that hole ever so slightly. These are looking pretty good so far. That one looks excellent. Once we get that, we have now the place for the brad point of our drill bit to go into and then track perfectly straight, and we'll go to the drill press to actually drill those out. One of the techniques that's really hard to see when I'm shooting this video is that when I first guide that drill bit down and that brad point goes into that pilot hole, I use a somewhat loose grip laterally, but I'm focusing more on just holding down, just lightly. And when that brad point goes into that hole, it may shift the wood ever so slightly, and I let it do that because that's the brad point lining up into the pilot hole. And then once I feel like it's got that alignment, I then go down nice and easy until I see it first score where that hole is, and I look to see how that is relatively centered to the holes that I drew with a pencil on there. And when I'm happy with it, I lock everything with a nice firmer grip and drill all the way through. That's the description of what I was just doing in that short little clip that I sped up. Have I mentioned my bouncy chair and how comfortable it is? I think I did. All right, so now what we're going to do is mount the neck into the neck pocket, and then we're going to mark to transfer the holes and the location into the back of the heel. I'm just going to slide this neck into place and make sure that it's firmly seated and firmly tight against basically the upper horn side of that cavity. If your neck isn't super duper tight, you can get away with that with a bolt on, but for the marking, you may want to be extra careful and grab a clamp and clamp that into the position that you want it. So this is tight enough here where I'm not so much concerned about it. The marking is pretty easy. The best tool I found for that is the drill bit that you just used. The brad point drill bit, if it's inserted into the hole you just drilled out, and if you just rotate it by hand ever so slightly, it will give you your new mark. And that technique also keeps it nice and perpendicular because it's following the sidewalls of the heel that you just drilled out. Now, depending upon how hard that maple is or whatever you're using for material, it may be hard to see. So just take a little lead and insert it into that slight little dimple that was made. And that will make it easy to identify where the little dimples are. Now here's the tricky part. For our threaded insert, we want a hole that is not too big or that threaded insert won't bite securely. We don't want it too small or it will be really hard to get it in there, and you may have a tendency to strip out that top little slot in there, and that will make it difficult to either go the rest of the way in or to get it out if you decide to abandon and put a new threaded insert in. Now I will tell you this, I did mention stainless steel is what I use. There's more commonly available to most people, you'll find ones made out of brass. And although I've seen people use those, I prefer not to. The stainless steel is much harder, less apt to get cross-threaded and stripped, and less potential problems somewhere down the road. A little bit more expensive, a little bit harder to find, but you can find them online, and I order them in quantity whenever I need them so that I always have a bunch on hand. So to get the right measurement that we need, we can take the calipers and we can go onto the fat part of the calipers and measure the outside diameter. So I have 0.327. Okay, so 0.327 is really close to 5/16. So if I take the tip of my caliper and insert that in between the grooves of the thread, then I've got 1/4 inch on the inside. Now that is going to be really tight in a hardwood. If I was using a softer wood, let's say I was putting threaded inserts into mahogany, Honduran mahogany or something like that, I would probably use a 1/4 inch hole because it is going to slice into that wood a lot easier. But when you're working with harder maples, I find the 1/4 inch hole is still too small, and it really takes a lot of force and effort to get that in, and again, things can go wrong pretty easily. So I will go slightly larger. Well, what's larger than 1/4 and less than 5/16? It's probably a drill bit that I don't have. So I'm going to compare in millimeters, and I look at the outside of the thread is 8.3 and the inside is 6.28, right? Okay, quarter inch. What is between those two? Well, that's 7 millimeters. So if I shoot in between those two numbers and I use a 7 millimeter drill bit in harder woods, I'm going to get better results. That's my personal feeling there. And magically, right here, I have a really nice and sharp 7 millimeter drill bit. Now, the other thing we've got to figure out is how deep are we going to take the holes. And if, again, I measure this here, I can measure that I've got 9.5 millimeters is the overall depth of these, which happens to be approximately 3/8 of an inch deep. So you're thinking, what are we going to do? We're going to drill 3/8 of an inch hole. Am I right? Is everybody thinking that? No, that's not what I'm going to do. I'm going to go about a millimeter deeper than that. So why, Steve? Why are you going to go a millimeter deeper? Okay, here's why. Because I'm going to actually countersink those holes by a little tiny bit, about a millimeter. And what that does is that makes sure that these threaded inserts are always below the surface of the wood. If you went and shot for dead perfectly flat on the top and you missed it by a fraction of a millimeter, that's a problem. Okay? If you shoot for a millimeter recessed and you missed it by a fraction of a millimeter, it ain't no problem. That's why I do that. Now, I will drill this on a drill press. There is no substitute for the accuracy of a drill press to get those holes perfectly perpendicular. If they're offset to an angle because you tried to shoot it with a hand drill, it could be close, but it may not be perfect. And when you drop those screws in through the back of the body, if it doesn't line up perfectly, you may end up having to drill bigger holes in the neck body to allow that bolt to shift left or right, up or down a little bit in order to start the thread and pull that neck tightly together. Will it work in the end? Yeah, it will work, but it's not right. Okay, so you want those holes as close to perpendicular as possible. The problem with a completed neck of this at this stage is that we have a radius on this neck. So if we have this sitting on a solid surface, drilling a hole on either of the edges of the fretboard, it's going to tend to push it and rock it over so that it is not perfectly perpendicular to the travel of that drill bit. So you could build yourself little shims under here, but that's kind of a pain in the neck. So this is a good time to talk about something that is near and dear to my heart. We're talking about jigs, right? So this is a jig that I built for a whole different purpose, but I use it for what we're talking about here. The purpose of this jig was originally designed for when you're shaping a neck by hand. I can set this platform up, which just happens to have a concave rest area for the fretboard that roughly matches, it's probably about 12-inch radius in there, which is going to be close enough for 10 to 14. You know, it'll sit in there, it'll cradle in there just fine. And I've covered it with leather so it kind of does absorb a little bit of the energy and kind of sink into it and kind of settle and become nice and firm in there. But this is designed for that, so I can take it and use the old safety planer on the drill press to slide this back and forth and begin to put a taper on there. And the reason why it produces a taper is because underneath that platform I have a tapered wedge under there. This happens to go from 9 to 12 millimeters, which produces from the 1st to the 12th fret, it produces a 3 millimeter taper in that neck, which is the standard I use. For hand carving, this is a necessary place for that. If you're using my jig, well, you probably aren't using my jig. But if you have a jig similar to the one that I used for my neck carving in a previous video, I don't need to do this step because that jig takes care of it. But for hand carving and for what my students are doing in class, this is what I show them as a technique of how to accomplish that. Now, let's turn back the clock to what we're talking about here today. And I'm trying to get the neck perfectly flat and level and not twisted one way or the other. This platform helps with that. But we do not want to taper, so I take just a 1/4 inch straight spacer, and the only reason I need that spacer is because the hinge that I have on the one end of this to kind of hold this whole apparatus together and allows it to be adjustable. If I put that in there, it kind of takes up and fills up the gap of that hinge, so I'm perfectly flat at this point. Now we can take the neck and we can shift it so we still have full accessibility to the drill press, okay, to all of our holes, and make sure that is centered in the middle of my caul. And I can then clamp that down and then clamp this other side down, and that will hold the neck perfectly flat, perfectly straight, so that when I take this platform to my drill press table, those holes will be drilled perfectly centered. All right, let me point out another just little finesse, little nuance here. We've got a table on the drill press. I had to adjust the height to accommodate for this jig here and enough space for my drill press to, or the drill bit to get under it. So while I'm doing that, why not just offset? These drill press tables are designed to be swung left and right and still be able to lock down and perfectly stable or perfectly square. So if I offset it to the right in this particular case, I can get more support. If that drill bit was on the center, then most of my jig is falling off the edge, and therefore it's not going to be stable. This is going to be a lot more stable. So I've already come down here, and in my drill press I've set the 0 function to 0 out there, and I told it I wanted to go 0.425 inches. All right, that is just under 11 millimeters, between 10.5 and 11 millimeters, which is going to be exactly where we want to be. And so now I'm going to go ahead and drill out these holes. The little tiny countersink that I do, I'm perfectly okay with doing that by hand. But since I already have this set up, I'm just going to go ahead and set my depth stop right there, and I'm just going to do it on this machine. All right, I may have a tendency to overcomplicate things. And I'm showing you a lot of detail, and I'm sure some of you are shaking your heads saying, you know, it's not that hard. You know, you just drill the holes, you insert the threaded inserts. But what I'm covering in detail is things that I've had trouble with in the past. And so if you're new to this, you don't have to figure it out, you know, on your own. If you're experienced and you've done this many times and you have a different technique, then keep doing it that way. All right? Remember, whatever works for you is right for you. That's the motto. Let me show you a close-up of a couple things real quick. So first off, here are our holes and the little tiny countersink on top. All right? That's my technique. That's the way I do it. You can see it's extremely subtle, not much. When you go buy these threaded inserts, there's a little slot at the top of them, and I can give you a close-up if you need to, but I think you know what I'm talking about. And they also sell a special tool. It's called an Easy Lock tool, and it basically slides inside there, and it's got little flanges, tabs or something on the edges that fit into that slot, and then that's what turns it, screws it in, guides it into place, and that's the tool that they sell for this. I will tell you, I don't like that tool. I have a hard time keeping it extremely perpendicular, and sometimes that threaded insert just starts cross-threading into the wood at a minor angle, and I don't like that. Sometimes I'm putting a lot of pressure on there because the wood's so hard, and those little tiny tabs begin to wear off, you know, and strip out, and that becomes frustrating. What I use is a little homemade device that looks like this. All right, I've got an 11/32 socket right there. I've got an 832 screw that I ground off the head, and then I use two nuts. One happens to be locking. The other one is just locked against that one with friction. And what is going to happen is that is going to thread inside of the threaded insert all the way till it hits that first nut, and then my ratchet, then my socket with a hand driver is then going to slip over top of that whole bolt assembly, and then I'm going to screw the insert in, and that will help me keep it a lot more perpendicular and a lot nicer. In fact, when my socket taps out on the surface, then I know I'm done. So I'll just keep it in here. It's holding it down nicely. I may have to clamp it in place if I can't properly support it. But look at this. Okay, that screws in. All right, we will place it right over the top. And now I will focus on holding that screwdriver as perpendicular as I possibly can while driving that into the wood with good pressure, without any risk of it slipping out. But that does take a lot of pressure. And like I said, when that socket hits the surface, I can't go any deeper, but that just so happens to be the perfect depth. Now a little lefty-loosey turn, and that breaks free from the threads, and I am left with a nicely recessed, perfectly perpendicular threaded insert. Let's look at that close. Ain't that sweet? It is the easiest way that I have found to do this, and the threaded insert and the bolt is the best way that I have found to secure a neck to a body. I'm going to go and do the other ones in fast time. Now we'll take it out of our hold down jig. Very simple jig, but again, worth taking the time to make little things that make other processes easier for you. That's what I'm saying. Now, if we did our job right, when we line that on and take our screws, they will drop right in and begin to thread. And again, thread by hand. There's no need to get a power driver out for this because you don't want to cross thread or mess anything up. Now once you get them started by hand, now you can get the screwdriver out and just start tightening them up. I don't over torque them initially. I try to get them just a slightly snug so that kind of they all center properly. And then I'll just kind of go around the horn and get a little bit more leverage on that. That is one super tight, super strong neck joint. What you've just seen is exactly what I was afraid of. I went into far more detail than I was originally planning to, and that's going to eat a lot of time, I think, in post-production, and it'll make the video too long. One of the stats on my video page, again, was of my videos that average probably 25, 28 minutes in length, the average person only watches 10 minutes of it. So if I make this video too long, nobody will watch it. So I'm going to cut it off right here now that you've seen the entire highly detailed, maybe overly detailed, maybe way too much detail for you, what you guys want to see, of how I use threaded inserts and bolts to make super strong neck joints. So that is going to be the end of this episode, and like I was talking about in the beginning about doing the whole alignment process, let's save that for the next video just so we can break this up into little tiny modules a little bit better. All right, sound good? So that's it for this episode. Until next time, remember, no matter what you do, start with excellence.